last video we introduced density and relative density, and in this video we're going to have a look at a very common type of question that they like to ask, and it's mixing substances. So the questions I'm going to go through here are from exercise 9a in the Folan's book, and one of the questions I'm going to go through, question 7, you actually did have for homework, so you might have got it, but it was a tricky question. Well, it's tricky if you don't know how to do it, but once I show you the kind of way of doing it, they're not too bad. So I'm hopefully going to get through 3 examples. I mightn't finish each question fully. I might leave you with a little bit to do. But what's important here is the technique as to how to approach these questions. So this is question 6 first of all. We have 60 milliliters of water. Well, that's the volume of water. So what I like to do is I write down the information first. So V water is 60 milliliters. Now obviously we need to change that into our SI units. So that's 60 times 10 to the power minus 6 meters cubed. Is mixed with 40 milliliters of alcohol. So in the same way, that's going to be 40 times 10 to the minus 6 meters cubed. And alcohol has a relative density S of alcohol is 0.95. What I like to do is I just use the density, which would be 950. Water, we know the density of water. It's always 1000 unless they tell you otherwise. So they're mixed together. So the water and the alcohol are mixed together to give us a new substance, let's say total, and we're looking for the relative density of that substance. So in order to find the relative density, we find the density, and then we can find the relative density. Well, do we know anything else here about the mixture? Well, if we know the volume of the alcohol and the volume of the water, we can say what the total volume would be. It's the 60 times 10 to the minus 6 meters cubed plus 40 times 10 to the minus 6. So the total volume will be 100 times 10 to the minus 6 meters cubed. So that's all our information written down. Now here's how I always start these questions, and in the Folan's book you'll see different examples, but this is the way I like to start it. I start with this equation. The total mass is going to be the mass of substance 1, which is in this case water, plus the mass of substance 2, which is alcohol. So if you get the mass of water and the mass of alcohol, and when you mix them together, the total mass will be their individual masses added. Now we know that density equals mass over volume, so we could say that mass equals density times volume. So for total mass, we could write, well, that's the same as the total density times the total volume. For the mass of the water, that's the same as the density of the water times the volume of the water. And for the mass of the alcohol, that's the same as the density of the alcohol times the volume of the alcohol. Now you'll notice that I'm only missing one variable from this equation, so I can either use this, I start with this equation, and usually you're turning it into this equation using the density equation. So total density we don't know. We know the total volume is 100 times 10 to the minus 6. Density of the water we know is 1000. Volume of the water is 60 times 10 to the minus 6. Plus density of the alcohol is 950 times 40 times 10 to the minus 6. And I won't do it, but you can solve there to give you the total density, or sorry, I won't break it down, but the total density works out as 980. Now the question was to find the relative density, so you have to divide that by 1000 to give you 0.98. And that's your answer for question 6. The key thing I want you to get here is that this is your starting point. And this is the starting point for so many questions. So just remember that strategy or that technique. Now they do get a little bit trickier, but that starting point remains the same. So let's have a look at question 7. So here we have iron, and again we'll write down our information first. So we have iron of relative density 7. So relative density of iron is 7, which means the density of iron is 7000. Nickel has a relative density of 9, which means the density of nickel is 9000. They're mixed together and their volumes are in a ratio of 10 to 1. Right, so the volume's in a ratio of 10 to 1. So that means 10 to 1, where the volume of iron will be 10 times the volume of nickel. Isn't that correct? It will be the volume of nickel multiplied by 10. So you could say as well that there's 11 parts here. Different ways that you could approach this. Find the relative density of an alloy formed correct to 3 decimal places in this way. Okay, so I'm going to start it in exactly the same way. I'm going to say our total mass is going to be the mass of the iron plus the mass of the nickel. Because when you add the two of them together, this always has to be true, doesn't it? So mass is density times volume. So that means our total density multiplied by our total volume is the density of the iron multiplied by the volume of the iron plus the density of the nickel multiplied by the volume of the nickel. Now, we are looking for this total density. We don't know the total volume. We know the density of the iron is 7,000 times the volume of the iron. And we know the density of the nickel is 9,000 times the volume of the nickel. Now, what you can do, there's two different ways you can do this. What I like to do is this. I like to, or what I'm going to do here is I'm going to kind of write this as an equation. So we can say that the 10 times the volume of the iron, or if we know this ratio, that the ratio is 10 times volume of iron to volume of the nickel, what we can say is there's 11 parts. So let's just figure out in this equation what one part is. So how I'm going to do that is I'm going to say let one part equal V. Okay? So now when I write this equation here, we have the total density times 11V, because there's 11 parts, is equal to 7,000 times the volume of the iron. Now there's 10 parts volume of iron, so I'm going to write 10V, plus 9,000 parts the volume of nickel. There's one part of nickel, so I'm going to just write V there once. Now, what am I doing here? Why is this good? Well, all I'm simply doing is I don't need to know the volume of each one individually. I can find it at the end. But I'm just saying, well, there's 11 parts of the volume here, 10 parts of the volume here, and 1 part of the volume here. And this allows me to cancel the V's. And I'm left with rho T equals 11 rho T equals 7,000 times 10, which is 70,000, plus 9,000. So 11 rho T equals 79,000. Divide across by 11 and you'll get rho T equals 7182. So the total relative density is 7.182. So that's one way of approaching it. Another way you could approach it, I'm just thinking here out loud now, is you could probably sub in. So rather than what I've really done there is I said, well, let one part equal the volume of the nickel. So I'm saying that the total volume is 11 times the volume of the nickel, whereas the iron is 10 times the volume of the nickel. And the same thing happens, it will just all cancel. Last question, and I won't go through this fully, but how much alcohol of relative density 0.9, so we have relative density of the alcohol 0.9, which means density of the alcohol is 900, should be mixed with 100 milliliters of water. So we know the density of water is always 1000, unless they tell you otherwise. And we have a volume of water is 100 times 10 to the minus 6 meters cubed. And we're looking for volume of alcohol. How much volume of alcohol do you need to mix to this to give us a total density of 9625? Again, just start off the same way. Mass total equals mass water plus mass alcohol. That's density total, volume total equals density of water times volume of water plus density of alcohol times volume of alcohol. Now this one's an important one because this I actually think is one of the most common ones. Here's what I do here. You replace volume total with volume water plus volume alcohol. Because if you look at this, I have lots of different variables. And what I want to do is I want to minimize the amount of variables to make the equation solvable. So I can get rid of the VT variable and replace it with VW plus VA. And now I've removed one variable. And now what you'll notice is you actually know everything except for what you're looking for, which is the volume of the alcohol. So volume of the alcohol here, volume of the alcohol here. So we can say density total is 9625 times the volume of the water, which is 100 times, sorry, the pen's acting up a little bit here, as usual, 100 times 10 to the power of minus 6 plus volume of the alcohol equals density of the water, which is 1000 times 100 times 10 to the power minus 6 plus density of the alcohol, which is 900 times VA. And the only variable you don't know in that equation is VA, so if you solve that, and you can pause it and solve it yourself, you should get an answer of 60 times 10 to the minus 6 meters cubed.